This is hydrogen tap. What you're looking at here is a 9-volt miniature relay. I've had a number of emails asking me to show them how to hook up a water sensor. I stick to the principle, the KISS principle, if you probably already know that. That is, keep it simple, stupid. And that works very well. The simpler, the better. The other principle I keep to, if it works, don't play with it. Well, here's the relay. What I'm going to show you is how to hook this up. One of the things I will mention is I use a 5-volt relay, not a 9-volt relay. This is a 9. I couldn't find another 5, but this will work just fine. So on the bottom of the relay, in this one, and most of the miniatures are the same, you have, get a good shot of that, 3 posts here, 2, 3, and 2 on the other side. These 2 here go to the coil. In other words, when you hook a 12-volt battery or 9-volt battery to here, either plus or minus, it doesn't care, this relay closes. This post right here is common, which means this and one of these other 2 here will either turn on or turn off, depending on whether the relay's on or off. So the first thing we're going to do is hook a battery to this, show you how it works. And that battery, you see 2 black leads right there. There's a shot of my battery, and you can see the black lead on the right and the red on the other side. We're coming from the black lead, the black post there, and we're coming in one side of this coil. We're going out the other side of the coil, which is a black lead, since it's coming from the negative side of the battery, and I'm going here to an electrode or stainless steel screw. The stainless steel screw is what I'm going to be using for my water sensor. And I'll show you how that works in just a moment. You can see the other side of the battery, as we saw before, is the positive. I've got a red lead, and what I've done is hook that lead to another electrode. Now on some of the focus cells I only use 1. I'm now switching to 2 sensors. So these would be your water sensors. I'm going to put them down for a moment. Okay, there's our water vessel there that would be the focus cell, the tube that holds the water, and the electrolyte. In the electronic world or electric world we live in, if you put distilled water is what I use in all my cells. By itself, you don't get any conductivity through the water. In other words, if I put those 2 electrodes in the water and try to run electricity through it, it would not work, not without a tremendous amount of electricity. And I know I'll get email. There's always a way to shoot it across like an electric discharge by putting so much voltage on one side it'll jump through. But let's keep practical here. And in this vessel, if you put 2 electrodes in distilled water and try to run a battery through it, it will not go. The water is an insulator. It's not a conductor. Now what we do is we put electrolyte in the water because that's how the focus cell works. And now once you have electrolyte in the water, you have a conductivity from anything in this water to the other. It goes through the electrolyte. So what we've done now is we've got, you're probably ahead of me. What we've done now is we've got 2 electrodes. The red's coming directly from the positive side of the battery. The black is going through the coil of the relay. So when these two make contact, you can hear the relay closing. And since it's only 12-volt supply and it's going through the relay, there's no sparks whatsoever. Okay? So now we have a means to determine when these are together, because it closes the relay. What we're going to do is set this up in the water. You're probably already ahead of me, I know that. So now we put one in the water, put the other in the water. And we'll do that again here. One goes in. You can hear the relay closing. And they're not touching each other, they're just going, the current is just going through the water, through the electrolyte, which is making it easy. So obviously when that water level goes below here, the relay drops out. And you can see there we go. I'm getting conductivity from here to here. You can see how far apart they can be. What I've done is put 1/8 of a teaspoon of lye in this water. So with 1/8 of a teaspoon, you're looking at least 5 inches between the two electrodes. And of course, when the water hits it, that means we have enough water in the focus cell and do nothing. As the water goes down, it releases the magnet. Phone break. Okay. So back to the relay, right? The other part of the relay are the contacts. This one here, if you see this mark over here, that's telling me that when the relay is not activated, these two here are closed, which means I can run another battery from here, through here, through a light, and back to the battery. And that'll be green, or that'll be a red light. And that means since the relay is open, I've got a contact, that also means there's no water in the system, so you better fill it up. When the water makes the contact between the two electrodes, this contact right here, or this leaf, opens up and this one closes. So now we have conductivity between this and that one, and we have a green light that tells us everything's okay. So that's pretty simple. That keeps with the KISS principle, I think. Again, there's 1/8 of a teaspoon of lye in this water here, and we've got a 9-volt miniature relay, which I would put a 5-volt and a battery hooked to it. Again, if you want to go to my site, hydrogentap.com, I do want to tell you I redid the site. It looks much better, at least I think so. I got a lot of remarks about my site before. I think you'll like this. It's got a real good index set up in it. Make sure you refresh your screen, otherwise you're not going to be able to see the site. Go to hydrogentap.com. I've got the stainless steel plates up there again, and the focus cell obviously is there. I'll have other information up there. There is more information than there was before, and I'll be putting up a lot more now that I got the site organized. You can go to hydrogentap.com, or you can email me at johnaarons@hydrogentap.com.